Hi, welcome to Chapter 4, Section 2. We're going a little bit out of order, but we need to make sure that we can find imaginary numbers and pull them out and simplify radicals. And you may have no idea what I'm talking about, but you will by the end of this video. So we're going to start with simplifying radicals, because anytime you have a square root, okay, that is a radical. And we have to make sure it is as simple as possible. So if it's the square root of 4, well, what is the square root of 4? It's 2. So we need to be able to simplify these things even when it's not a perfect square. So the first thing you're going to do is write the number as a product of its factors. So you're going to take the number, whatever it is under the radical, and divide it by small numbers, such as 2, and 3, and 5, and 7. So our prime numbers. Then you're going to take out the factors that show up an even number of times. Each time it shows up twice, that's when you take it out. Then we're going to leave the rest under the radical and simplify on the outside. So, for instance, 49. Well, we're going to divide 49 by a prime number. Okay, so 2. Does 2 go into 49? No. Does 3 go into 49? No. 5? No. 7. 7 goes into 49, so we're going to divide by 7, and we end up with 7, which is also a prime number, so we're done. So I'm going to rewrite the square root of 49 as the square root of 7 times 7. So you can see how many times is 7 under the square root. Well, it's under there twice, which means that we're going to take it out and just get 7. Now, because we took everything out, there's nothing left. The square root of 49 is indeed 7. So let's try doing the same thing on something a little bit more complicated. Example 2 says to simplify the square root of 72. So we're going to come over here, write down 72, and start dividing. Well, is 72 divisible by 2? That's the smallest number we can use. Always start there. Yes. Well, 72 divided by 2 is 36. Is that divisible by 2? Yes. You get 18. Is that divisible by 2? Yes. You get 9. Is 9 divisible by 2? No. So we're going to go ahead and try 3. Is 9 divisible by 3? Yes. 3 divided by 3. And 9 divided by 3 is 3, so 3 cannot be divided by anything, so we're done. So we're going to come up here next to the 72 and write what we found. Well, we have 3 times 3, and we have 2 times 2 times 2. Okay, so everything that was on the outside of that little pyramid, and you can just write them up. So we're going to circle the ones that happen twice. The 3's happen twice, and one of the pairs of 2's happens twice. Or happens, right? We have one pair of 2's. Now, we are not going to take out the 2 that's left inside. Instead, we're going to take out one of the, or both of the pairs, right? But we're going to write it once. For example, instead of writing 3 times 3 on the outside, we just write 3. Okay, we write the number that happens twice. So the number that happens twice, again, is a 2. And then we leave the other 2 underneath. Well, we can't just write that it's 3 times 2. We have to write what 3 times 2 is, and that is 6. All right, let's try that again. We have the square root of 24. So we have 24. Is that divisible by 2? Yes, it is. We get 12. Is that divisible by 2? Yes, it is. We get 6. Is 6 divisible by 2? Yes. We get 3. So we're going to take everything on the outside and write it inside. So we have a 3 and 2 times 2 times 2. Now remember, we can only take out a pair. So if we take out one pair of 2's, we don't have any more 2's to take out. So let's take out just the 2, and then we have the square root of 3 times 2. But again, simplified is better. So we don't want to leave that as 3 times 2. We want to put that into a 6. Again, another example. 4 times the square root of 32. So we're going to do the same thing. So let's go ahead and start dividing that 32, see if there's anything that goes into it. 32, is that divisible by 2? Yes, we get 16. Divisible by 2? Yes, we get 8. Divisible by 2? Yes, we can get 4. 4 is also divisible by 2 to get 2. So we have 1, 2, 3, 4, 5 2's on the outside. Sorry. So we have 4, because that was already outside, times 5 2's. Okay, so we circle pairs. So that means that we can take out 2 2's because we have 2 pairs. So we have 4 times 2 times 2, and then left under the radical is still a 2. Well, 4 times 2 is 16. So we have 16 root 2, and that is the simplified answer. So anytime you have a number under a radical, you put it to the side and start dividing it by small numbers. Start with 2, then try 3, 5, 7. So what do you do if you have fractions? Fractions, guys, are not scary. Don't let them scare you. Because what you can do every single time is take the square root of 3 over 4 and write it as the square root of 3 over the square root of 4. And now it's not so bad because you can do this individually. 3 is not divisible by anything but 1, so we're kind of stuck with it. But 4, we can come over here, is 4 divisible by 2? Yes, it is. So we have 2 and a 2, so under the radical we can put 2 times 2. Well, that means we can take that out, so we have the square root of 3 over 2. Now, we only run into a problem with fractions when you have a radical left in the denominator. Here, we have a 2 in the denominator, so we're good. There's no radical left, so we can say that that is our final answer. Here's an example, in example 6, where you won't have that in your final answer, and I'm going to show that to you in 2 seconds. We have the square root of 16 over the square root of 32. So we're going to treat 16 as its own number and 32 as its own number because they are, indeed, their own numbers. So let's find what goes into 16. Well, 16 is divisible by 2, you get 8. 8 is divisible by 2, you get 4. 4 is also divisible by 2, you get 2. So all of this is going to go on the top. But we also have that 32, so let's go ahead and do that for the 32. 32 is divisible by 2, you get 16. Divisible by 2, you get 8, which is divisible by 2, you get 4, divisible by 2, and you get 2. So this is going to go on the bottom. So we have 4 2's on top and 5 2's on the bottom. So we get the square root, 4 2's on top, over our 5 2's on the bottom. And then we're going to pull out pairs like we always do. Okay, so we have a pair of 2 and a pair of 2, which means we can pull out 2 2's over. We have a pair of 2 and a pair of 2, and we have 1 2 left over. So we have 2 times 2 root 2. All right, well, let's go ahead and simplify those numbers. What is 2 times 2? It is 4. So we have 4 divided by 4 root 2. Well, we know that 4 over 4 is just 1. So let's go ahead and simplify that to 1 over root 2. All right, so here's where we have a problem. Okay, we simplified the 4's, which is perfectly fine, right? 4 divided by 4 is 1, so you're left with a 1. That doesn't go away. We have to be able to get rid of a 2, the square root of 2, and this is called rationalizing the denominator. So we are rationalizing it. We are making sure that there's no radical in our denominator. So in order to get out a square root, you multiply it by itself. Okay, so we're going to multiply the top and the bottom by the bottom. So we're going to multiply the top by root 2 and the bottom by root 2. And the reason we do this is because you're essentially, root 2 divided by root 2 is just 1. You're multiplying it by 1, which is perfectly legal in math. So we have 1 times root 2 on top is just root 2. And then we have the square root of 2 times the square root of 2. So I'm just going to stick them underneath the same thing. Well, that's a pair. So we actually end up with the square root of 2 over 2. That is our final answer, because this does not have a radical in the denominator. Okay, and that's why it always works, because whenever you multiply it by itself, you end up with a pair in the denominator. So then that pair comes out. All right, so along with rationalizing and simplifying radicals, we have these things called imaginary numbers. Now, you have real numbers, right? That's what we're used to dealing with. And that is perfectly fine. That's not going to change, but an imaginary number is not a real number. And here's how it is defined. I squared equals -1. Okay, I squared equals -1. When you take the square root of both sides, so if you were to take the square root of this side and the square root of this side, the square goes away and you get that I is the square root of -1. And so that's how we deal with negatives in denominators, in radicals. Because most of the time you think, I've got to take the square root of a negative number. Well, that's just not real. That doesn't exist. So now we're going to place a letter in there instead. So let me show you what this is going to look like. In example 7, the imaginary unit I can be used to write the square root of any negative number. So if you have a negative inside, this negative becomes this I. You're taking the -1 and you're turning it into an I on the outside. So for example, in number 7, we have the square root of -25. Well, let's go ahead and do that. The 25, is there anything that can go into it? Because we have to simplify every time. Well, there is something that can go into it. It's not a 2 or a 3. It is a 5. And 25 divided by 5 is just 5. So we can rewrite -25 as -1 times 5 times 5. Now, we can circle pairs, but you can always circle a -1. Because that -1 is going to come out. And when it comes out, it becomes an I. So we have an I. And then we have a 5. Right? We can take one of the 5 out because it was a pair. So our final answer is 5I. Let's do that again with something a little bit more complicated. Make sure you understand how to do it. We have 72. Well, that's divisible by 2, right? That gives us 36, which is divisible by 2. That gives us 18, which is divisible by 2 to give us 9, which is divisible by 3 to give us 3. So remember, we take whatever's outside and we write it underneath the radical. Except now we have a -1 also. So we have -1 times 3 times 3 times 2 times 2 times 2. So we can take out -1 and we can take out pairs. All right, so we have a we have a 3 to take out times a 2 to take out times a -1, which becomes an I. And then we leave the square root of 2 underneath because the 2 didn't have a pair. We can simplify this, though. 3 times 2 is what? Well, it's 6. So we have 6I root 2. And that's it. That's our answer. One more time. We have -5 times the square root of -9. So, just like we did with example 4, on the other side of the paper, right? If you look, we just left the 4 out there by itself. We left it alone. We just dealt with what was on the inside until we started simplifying. So let's do the same thing. 9. Is 9 divisible by 2? No, but it is divisible by 3. So we have 3 times 3. So this means that we have -5 times the square root of -1 times 3 times 3. Now we know that there's a negative because it was -9. So we can take out the -1 and we can take out a pair. So now we have -5 times 3, and the square root of -1 is I. So that gives us -15I when you multiply the -5 and the 3. All right? So that's how you simplify with an I, okay? But we can have a combination of real and non-real numbers, the real and the imaginary, and those are called complex numbers because they're complicated, but not really. Okay, and that's A plus BI, where A and B are real numbers, and you just have a number in front of I. Like we had the -15I. That would be the BI, and there would not be an A at all. So you can add and subtract, multiply complex numbers just like you would any factors, right? We've been factoring, so we're going to do the same thing. whenever you have an addition symbol in front of or whenever you have anything between parentheses, you have to distribute. So when we're adding or subtracting, there's something in between. So we're going to distribute that. So let's distribute the addition. Well, anything positive times whatever sign it is stays the same. So we have nothing happens to the 8 minus I. We are not distributing the 8 minus I. We're distributing the plus sign. So 8 minus I automatically stays the same. Then we have a plus 5 and a plus 4i. So now we're going to circle our numbers, and box our i's, just like you would with any other like terms. The like terms are the numbers and then the i's. Okay, you cannot put them together because the 8 doesn't have an I with it. So we're not going to subtract I from 8. We're just going to write 8 minus I, just like it was in the problem. So 8 plus 5 is 13, and 4 i's minus 1 I is 3i. And that's our final answer. Let's try that again. Now with subtraction, you do distribute, right? You're distributing it anyway. But when you distribute, it changes the sign. So we have 7 minus 6i, that did not change because we are not distributing that. We are distributing a negative. A negative times a positive 3 is negative 3. A negative times a negative 6i is positive 6i. Well, now we can go ahead and we circle our numbers and we box our i's. So that 7 minus 3 is 4, and negative 6 plus 6, that goes away. So 4 is our final answer. Let's try that one more time. Now here, the negative is all we are distributing. We are only distributing the negative, not the 13. Not the 13. Okay, the 13 stays the same. We have negative times 2, which is negative 2. We have a negative times 7i, which is negative 7i, and then plus 5i. So we circle our numbers, and we box our i's. Okay, which happen to be next to each other. 13 minus 2 is 11, and negative 7 plus 5i is negative 2i. And that's our final answer. One last thing you have to be able to do is double distribute, right? We were able to do that in distribution with x's and, our factors. So this is the same. Okay, we're going to distribute the 4i inside the parentheses. For example, 9, part A. So you have 4i times negative 6. Well, 4i times negative 6 is negative 24i. Right? Because you're just multiplying the numbers out front. Then, we're going to multiply 4i times I. Well, I times I is I squared. So we're going to have plus 4i squared. Now, if you look at the top of your page, it says that I squared equals negative 1. So instead of keeping that as I squared, we are going to write negative 24i plus 4 times negative 1. Well, 4 times negative 1 is negative 4. Now, we have to do one more thing. In order to write it in standard form, it has to be a plus bi. Right now, we have bi plus a. So we need to take them and swap them. Just swap their places so that we have negative 4 minus 24i. All right, last one. We are actually double distributing. So we have to distribute the 9 to the other side and the negative 2i. So we have 9 times negative 4. Well, that is negative 36. We have 9 times 7i, which is positive 63i. Okay, well now we're going to distribute the negative 2i, so we have negative 2i times negative 4, which is positive 8i. Right, and remember I write it underneath each other so that my like terms are already aligned. And negative 2i plus 7i is negative 14i squared. So now we're going to combine down, and we get negative 36 plus 71i minus 14I squared. But the point of the last problem was to show us that I squared is not just I squared. You have to simplify that because I squared is negative 1. So we have negative 36 plus 71I minus 14 times negative 1. Well, negative 14 times negative 1 is a positive 14. So we end up with positive 14 over here. Nothing else changes. And then we combine our like terms, which are the numbers. So we have 12 plus 71I. And that's it. Have a great day.